हेलो स्टूडेंट्स, नाउ आज हम क्वेश्चंस पे डिस्कस करने वाले हैं दैट इज बेस्ड ऑन योर एरर्स. सो इन दिस क्वेश्चन बेसिकली यू आर गिवन that in an experiment to determine the acceleration due to gravity by the simple pendulum, right? और उसमें स्टूडेंट ने 1% पॉजिटिव एरर कमिट करा है, राइट? दैट इज गिवन टू अस व्हाइल मेजरमेंट ऑफ लेंथ को मेजर करते समय जो एरर है दैट इज 1% एंड दैट्स अ पॉजिटिव एरर एंड 3% नेगेटिव एरर इन द मेजरमेंट ऑफ टाइम पीरियड, राइट? सो 1% पॉजिटिव एरर इन मेजरमेंट ऑफ लेंथ है एंड 3% पॉजिटिव एरर इन मेजरमेंट ऑफ टाइम पीरियड है, राइट? और हमें बेसिकली परसेंटेज वैल्यू ऑफ जी, उसमें जो एरर है दैट इज वी हैव टू कैलकुलेट परसेंटेज एरर व्हाइल मेजरमेंट ऑफ जी, राइट? सो हमें फॉर्मूला पता है. व्हाट डज द फॉर्मूला वी हैव? दैट इज टाइम पीरियड व्हिच इज व्हाट 2 पाई अंडर रूट ऑफ व्हाट L by G. Now that's the formula for time period. Now we'll square both the sides. So we'll have t square is equals to 4 pi square L by G. Now why we have squared? Basically यहाँ से हमें G की वैल्यू चाहिए, right? So अगर हम यहाँ से G की वैल्यू इवेल्युएट करें, so G comes out as what? 4 pi square L upon T square. Now that's the formula for G. And now ये formula हम use करने वाले हैं to calculate the percentage error in G, right? तो कैसे होगा देखते हैं बिल्कुल. So we have the formula that is G is equals to what we have 4 pi square L by T square, right? Now बहुत सिंपल लॉजिक है. दैट इज हमने मल्टीप्लीकेशन डिवीजन या पावर से उस केस में हमने फॉर्मूला पढ़ रखा है टू कैलकुलेट द एरर. सो दैट इज व्हाट बेसिकली डेल्टा जी बाय जी, राइट? एंड इनटू 100. दैट्स यू एक्सप्रेस्ड इन टर्म्स ऑफ, अगर सिर्फ डेल्टा जी बाय जी लिख रहे हैं सो दैट्स अ रिलेटिव एरर. डेल्टा जी बाय जी इंटू 100 लिख रहे हैं सो दैट्स योर परसेंटेज एरर. सो डेल्टा जी बाय जी इंटू 100. नाउ द कांस्टेंट हैज नो यूज इन दिस. सो वी हैव एल एंड टी, दोज आर द वेरिएबल्स मींस. सो वी हैव डेल्टा एल बाय L into 100, right? Plus of we have delta T by T into 100, and whatever the powers we have that will be in multiplication. So power of T is 2, so you will multiply this delta T by T into 100 with 2, right? Rest the powers is 1, so no need to multiply, right? Now we have the percentage error of this delta L by L. Now that's given us 1%. Right, so this is 1%. This will be 2 into what? 3%. So in total we have 1% plus 6%. So that gives us 7%. Now do remember whether the error is positive or negative. In this we'll just take a magnitude, right? So we'll have 1% and 3%. So 2 into 3% is 6 and 6 plus 1 is 7%. So the percentage error in calculating acceleration due to gravity is going to be your 7%. So that's the answer. I hope you understood. So which option is going to be the correct one? We have the option number A. That will be your correct answer. I hope you understood well. Now we'll move further. So we have another important question, that is when a current which is given as 2.5 plus minus 0.5. Now that's the value of I, right? And that we can say this is your what? Delta I. Right? Now that's the expression for current, and the potential difference is given us. Now that current is flowing through a wire and develops a potential difference of 20. So this is V and this is what? Delta V, right? So this is I plus minus of delta I and this is V plus minus of what? Delta V, and we have to find the resistance of the wire. So first of all, if I ask you the formula for the resistance, now we very well know Ohm's law. V is equals to IR. So R can be written as what? V by I. Now we are going to apply the concept of error in division, right? So what's the concept? We have delta R by R, right? And that is equals to what? Delta V by V plus delta I by I. Now we have the value of delta V. What is that? We have 1 and V is your 20. So we have 1 by 20 and delta is what? 0.5, and I is basically your what? I is nothing but your, you can see I is 2.5, right? Now the value of resistance, so you can calculate by keeping the value of V and I. Now what is V? We have 20 and I we have 2.5, so you can calculate R as well. So we have 20 divided by 2.5. Now 2.5 is basically your 5 by 2. So that becomes 40 by 5. So value of R comes out as what? 8. Now we want to calculate the delta R, right? So delta R will be basically this multiplied by 8, right? So we have what? We have inside this we have 1 by 20 plus of 0.5 upon 2.5. So we'll remove the decimal, right? So this gets cancelled out. 5 by 25 is what? 1 by 5. So 1 by 20 plus 1 by 5, and that has to be multiplied with what? That has to be multiplied with 8, right? So from here we'll get the value of delta R. So now on solving this, 1 by 20 plus 1 by 5, we have an LCM of what? 20, right? So you can solve this further. So we have delta R is equals to, on taking the LCM, you'll have 5 by 20, and that is basically multiplied by 8. So delta R comes out as what? 2. Now if you want to express this, so delta R is coming out as 2 and R is coming out as 8. So the error in the resistance of wire, that will be 8 plus minus of 2, and the measuring unit of resistance is going to be your ohm, right? So you can write the final answer to this question as your what? 8 plus minus of 2, and that 2 in ohms, right? So I hope you understood well. Now we'll quickly move to the next question. And now the next question is basically we are given few dimensional equations, means we are given few equations and we have to check whether they are dimensionally correct or not, basically, right? So we have H is equals to what? 2s cos theta upon R rho g. Now that's the formula which we are going to study in fluid mechanics, right? But for a moment, let's say we have this equation, we have to check whether this equation is dimensionally correct or not. Now for that, what we have surface tension denoted by S, we have density denoted by rho, we have height denoted by h, and what is R? R is just your distance, and g is what? Acceleration due to gravity. So basically the new things which you can see over here is surface tension, which is denoted by S. Now what is surface tension? So basically surface tension is the property of fluid. Now again, that is you are going to study in fluid mechanics, but for a moment I'll tell you what is surface tension. It is a property of fluid by which it tends to have minimum surface area, means its tendency, basically if you keep a liquid in a container, so it will occupy that kind of shape so that it can minimize its surface area, right? So there will be a force acting per unit length. Now that's the formula for surface tension, right? So if I ask you the dimension of surface tension, now you know the dimension of force. What is the dimension of force? Dimension of force is basically mLT minus 2, right? Mass into acceleration, and acceleration is LT minus 2 and divided by L. So the dimensions of surface tension is what? MT minus 2. Now you can keep the dimensions on the right hand side. So for the surface tension we have what? MT minus 2, right? We are least bothered with 2 and cos theta, because cos theta is a dimensionless quantity and 2 is also constant. Now we have rho. Now rho is what? Density, and density is what? Mass by volume. So we have ml minus of 3 and multiplied with what? Distance. So that is L. And then we have acceleration due to gravity. So that is what? LT minus of 2. So once you solve this further, so what's going to happen? You have over here L into L is what? L square. See, obviously m is going to get cancelled out. T minus 2 is also going to get cancelled out. So what remains in the denominator as L to the power minus 3 and L to the power 2. So that becomes L to the power minus of 1. And in numerator, we are left with nothing. So we have 1 upon L minus 1, which has the dimension of L1, M0 and T0. Now ultimately we have L1, right? Rest will be 0. So height also have the dimension of length. So this equation means the left hand side and right hand side are the same. So this equation is going to be dimensionally the correct one, right? I hope you understood. Now we'll quickly move to the next one. We have V is equals to under root of P by rho. Now what is V? V is basically over here speed of sound. P is what? P is basically your pressure and rho is your density. Now we know the dimension of V. What are the dimensions of speed? Speed is basically distance upon time. So it is going to be simply LT minus of 1. Now that's the dimension of left hand side, right? LHS has this as your dimensions, right? Now we'll quickly see to the right hand side. So we have what? Pressure and density. Now what is under root of pressure and density? So pressure is what? Pressure is force upon area. Now force is MLT minus 2 and divided by area, that is going to be L square. You can see it. So I'll be talking about pressure. So that is basically force per unit area. Now dimensions of force is what? MLT minus 2 and divided by we have area. So that is going to be L square. So you solve this, you will have what? You will have ML minus 1 T minus 2. Now that's the dimension of what? Pressure. So we'll keep this. So we have ML minus 1 T minus 2 whole divided by what do we have? We have density. Now density is again mass by volume. So dimensions of density is going to be ML minus 3. Now what you can see? This M and M is going to get cancelled out. Now this will go in the numerator. So you'll have what? You will have L2 T minus 2. Now we have the square root. Square root means what? Square root means whole to the power what? 1 by 2. Now powers gets multiplied, right? So what we are left with? We are left with what? LT minus 1. That means L1T minus 1. Now that's the dimension of which side? These are the dimensions of right hand side, right? Now you can see that the dimensions of right hand side comes out as same as the dimensions of left hand side. That is L1T minus 1. This is also L1T minus 1. If it is nothing like written, so you consider it as L1, right? So the dimensions of the two sides are equal. So definitely this equation is also dimensionally the correct one. I hope you understood. Now we'll quickly move to the next equation where we are given V as volume, right? P as pressure, R is just a distance, N is what? Coefficient of viscosity, L is length and T is time. And we have to check whether this equation is dimensionally the correct one or not. So first of all, we'll start with the left hand side. So left hand side is basically your volume. So volume has dimensions of what? Volume has dimensions of L cube. Now that's the dimension of left hand side. That's very simple. Now we'll see right hand side of this. So on right hand side, what do we have? Right hand side we have pi by 8. Now that's basically your Poiseuille's formula that again you will study in fluid mechanics. So pi by 8 is a constant. I'll keep it separate. So what do we have? We have P r to the power 4 multiplied by T, and then we have what? We have eta L. Now eta is coefficient of viscosity and L is just your length. So we'll apply the dimensions. So dimensions of pressure. Right now we have seen that is pressure is force upon area. So force is what? Mass into acceleration divided by area. So MLT minus 2 divided by L square. So that is going to be what? ML minus 1 T minus of 2. Now that's the dimension of what? Pressure. Now we have R to the power 4. R to the power 4 is going to be basically L to the power 4 simply, right? Then we have time. So that will be simply your T, right? Now we have eta and we have length. So for the length we'll have L. And now we'll talk about eta, that is coefficient of viscosity. So basically coefficient of viscosity, we have the formula force is equals to eta A dV by dx, right? That is velocity gradient. This you will study in class, the same grade but in fluid mechanics. So from there you can calculate the dimensions of eta. So force we know that MLT minus 2, and now dx will go that side. So we'll have L. Now eta area will divide, so we'll have what? L square. And now dv is basically your, over here it is velocity gradient, so that is L. Now dv is LT minus 1, because dv by dx is going to be what? LT minus 1 upon we have L. So dv by dx is basically velocity per unit length. So we'll divide L and L will get cancelled out. So you can do it in that way as well. Otherwise you can simply take it as T minus 1. The dimensions of this is going to be what? T minus of 1. So whatever you feel comfortable, you can solve this. So you can solve this further. So this L square is going to get cancelled out. So what we are left with? We are left with M L minus 1, and this minus 1 will go in numerator. So we'll have again T minus 1. Now that's the dimension of what? Coefficient of viscosity. So we'll put that. So we'll have what? M L minus 1 T minus 1. Now we have to solve this further. So see, this m and m is going to get cancelled out, right? Now this is t minus 2 and this is t, so that becomes t minus of 1, and that will cancel with t minus of 1, right? Now this L will cancel with L minus 1, because L minus 1 is 1 upon L, so it will cancel. So what we are left with? We are left with L to the power 4 and L minus 1. On solving this, we are going to get what? We are going to get L cube, right? So that's the dimension of right hand side, and also the left hand side has the same dimensions. So again, this formula is dimensionally the correct one. Fine. Now we'll quickly move to the last one. We have formula for frequency, that is 1 upon 2 pi under root mgl by I. Now what does this m denotes? M is basically your mass, F is your frequency. Do remember, frequency is reciprocal of time period, right? Now what do we have? We have acceleration due to gravity. Now that is basically your g, right? And I is your moment of inertia. This you will study in rotational, but for a moment you can know this formula, that moment of inertia is denoted by mr square, right? So you can check this equation whether it is dimensionally correct or not. So first we'll start with the left hand side. So in the left hand side, what do we have? Left hand side we have frequency. Now as I said, frequency is reciprocal of time period, so it has the dimension of what? T minus of 1. Now that's your left hand side. Now we'll quickly move to the right hand side. So what do we have in the right hand side? We have 1 upon 2 pi, so that's again a constant, so we are least bothered with that constant. Now we have what? Under root mgl by I. Now we'll put the dimensions of m, so that is simply m, right? Mass के dimensions m होते हैं, right? Acceleration due to gravity के dimensions क्या हो जाएंगे? Lt minus 2. Then we have L, and then in the denominator we have moment of inertia, whose formula is what? mr square. So dimensions क्या हो जाएंगे? Mass का तो m रहेगा, r square मतलब L square हो गया, right? So we'll have the dimension is what? ml square. Now m will get cancelled out, L square will get cancelled out. So simply we have t minus 2 and raised to the power 1 by 2. Now power gets multiplied, so we'll have what? T to the power what? We have minus 1. So that's going to be the dimensions of the what? Right hand side. Fine. So left hand side also has the dimension of t minus 1, and right hand side also have t to the power minus 1. So again, this equation is dimensionally the correct one. So I hope you all understood well. So that's the end of it. Thank you.